Hi, Assalamualaikum. So, we will explain about the machinist analysis question, which is about submarine. From this question, we know that a student designer want to design a submarine using prototype submarine with length 4.85 meter. They hope that submarine can submerge in water with temperature 15 degrees Celsius through 0.014 meter per second. The designer built a 1/5 scale model to test. So, what the velocity of model when the temperature is 25 degrees Celsius?
Hi! Okay, now from the question, we can get information. So, from the information, we divide to prototype and model. So, for the model, we get temperature at 25 Celsius, which is from the table at temperature 25 Celsius, we can get rho and mu. And for the prototype, we get information about the length and also the velocity. At the same time, we have the temperature at 15 Celsius. So same, from the table we get mu and also density. So the question is, it asks we to find velocity of the model. So we know that Reynolds number of prototype equal to Reynolds number of model. So we can equal after derive, we get this equation. So we substitute the information to get velocity of model. So here, LP over LN, we got from the question, it say that the scale is so LP and we got AA, we got 5. So here we substitute 5. So we get 30.2 meter per second. So we're done. So the answer is 30.2 for velocity of model. That's all for me, Aishah. Thank you.
Next, for second question, this question asks to find drag force on prototype submarine at the conditions same with problem 1, which is for prototype the temperature is 50 degrees Celsius and the length is 4.85 meter and velocity is 0.44 meter per second. Then for the model, we know that the designer wants to build 1/5 scale model at 25 degrees Celsius. From problem 1, we already know the velocity, which is 30.2 meter per second, and their measured drag force is 5.70 Newton. So the question is, what is drag force from prototype?
Hi. From the question, we already know the temperature for the prototype is 50 degrees Celsius. So we need to find rho and mu from the table. After that, we also know the temperature for the model from the question. And then refer the table, we know the rho and mu. So from the first question, we already know the velocity of model, which is 30.2 m per s. So for this question, we need to find force drag force. So we know the drag coefficient for model equal to drag coefficient for prototype. So using this formula, we need to substitute all the information we get into the equation. Then from the question, we already know 1/5 LP equal to LM. So LP over LM equal to 5. So we substitute 5 into this, and then we get the answer for F. The prototype is equal to 25 over 0.5 Newton. So I think that's all from me. Thank you.
Okay, now for the next question, it asks to repeat the first question with all the same condition, except the scale model of the submarine. Now the scale is 1/24 scale model instead of a 1/5 scale model. We already know that the prototype temperature is 15 degrees Celsius, the velocity is 0.44 meter per second, and the length is 4.85 meter. And for the model, we know that the temperature is 25 degrees Celsius. So now the question is, what is the velocity of model if using 1/24 scale model?
Okay, so for this question, we already know the L, the V, and also T for both prototype and model. So for the table, we know that when the temperature is 50 degrees Celsius, we already know the density and also the dynamic viscosity. Also, same goes to when the temperature is 25 degrees Celsius. Okay, so the question asks for the velocity for the model. Okay, as we know, the Reynolds number for the prototype and for the model are equal. So we know. Okay, so we want to find the velocity for the model. So we can. Okay, so we already know all the value. So we can substitute the value. And for the LP over LM, from the question we already know that it says 1/24 scale of model. So it's actually 1/24 LP equal to LM. So we know that LP over LM is equal to 24. So we can substitute here 24. Then we can get the answer, which is the answer is 145 meter per second. Okay, that's all from me. Thank you.
So for the repeating variable is, what I understand about repeating variable is, repeating variables is a set of variable to form that cannot form the dimensionless group, which is if we use the variable and we cut that unit, the value is 0. So we have to form not a unit, a symbol, such as in fluid we found length, density, rho. This is some of the example of repeating variable, because in length the unit is m, and density is kg over meter squared, meter cube. So this is some of the example of repeating variable. After that, another example of repeating variable is Reynolds number, which is rho BL over mu. In this Reynolds number,
Rho is stand for kg per meter cube, V meter per second, L m, and also mu kg per kg m dot s. So this is meaning of repeating variable. Repeating variable, so that if we cannot cut the repeating variable, we place it with the symbol. That's all from me. Thank you.
Hi, for this topic we need to know what is repeating variable. Repeating variable are any set of variable which cannot form any dimensionless group. So for example, which is velocity and diameter. So this kind of dimension cannot be arranged in any way because the units will be cancelled out. So they will form a set of repeating variable. So actually for this topic, we can see from Reynolds number. So Reynolds number cannot arrange their unit because it will be zero at the end. So actually Reynolds number is the repeating variable. So that's all from me.
Okay, the repeating variable is actually any set of variable that cannot form dimensionless group. For example, diameter, height, and velocity is actually they cannot be arranged in any way that can cancel the unit. So for the example for repeating variable is actually Reynolds number, which is rho v d over mu. So that's all for me. Thank you.